So we're going to kind of read a situation and then pick a graph that goes with it. So just remember that time always moves forward. So, and when we talk about like speed or distance, we're going to use like positive and negative slopes and slopes that are zero uh, if it's holding steady. So let's just look at this first one. Ryan is driving on a freeway at a constant speed. So we immediately know that we're going to start with a flat line. So it's going to be either the first one or the last one. So he's starting at a constant speed. Then he speeds up to pass a truck. So we know that his speed is getting higher. So it's going to be a positive slope, which both of these are. After passing the truck, he exits the freeway and slows down. So he's going to have to slow down. This one at the end, he's maintaining a constant speed after, but we need him to slow down. So it's going to be the first one because it's going to go downhill. Now for distance from something, let's look at what it looks like. A bird of prey leaves the nest to go hunting. So he's how far away from the nest? So he's going to get farther away from the nest in the beginning. So the last three are kind of increasing his distance from the nest. The first one maintains the same distance, which if he's leaving the nest, he's getting further away from. So we can't use the first one. It flies for several miles away from the nest before stopping to eat. So he's going to get further away. He's going to stop. So it's going to lay flat. So it's going to kind of go flat like these. After eating, it continues to fly away from the nest for several more miles looking for food. So it's going farther away. So it's going to be this last one here. So it was the first one and the last one on these, which is what they picked. So we are just kind of listening to the story and seeing how, if the graph matches it, like how it matches it. Okay, so let's look at this first one. Hong is working out by riding his bike. He starts by biking slowly at a constant rate. So constant is going to look like the first of the first three. It's just going to be flat. Then he gradually picks up speed until he reaches his peak. And then he maintains his peak for the rest of the workout. And maintains means that he's going to stay the same speed. So he's these ones, they all increase the second part. This one is going to continue to increase slowly. This just keeps increasing like forever. This one is the one where we're going to pick that he maintains his speed because then he's going to stay kind of constant. So now we're looking at distance from Scott's house. So when he leaves his house, he rides at a constant speed until he reaches a lemonade stand. Now they're trying to kind of trick you here because they introduce speed, but we're not talking about speed. We're talking about how far away he is from his house. So he is getting farther as soon as he leaves the door, he's getting further away from his house. So these two cannot be it because the distance from his house is not going to stay the same if he leaves his house. So it's got to be these two. He parks his bike and takes a rest. So we know the second part is going to be flat because he's staying the same the same distance away from his house. See, they got me confused too. Then he turns around and bikes home as fast as he can. So he's going to be starting to get closer to his house. So it's going to be this one. So we have to pay attention to what they're looking at in order to be able to pick the right picture. The daily amount of calories that a rat eats increases steadily from birth to about age 3 months. So the amount of calories increases. So it has to be this one because all the other stays the same. Then the amounts level off at about age 6 months. That's what happens. And then it increases again. So this is the correct one. A helicopter takes off from the roof of a hospital and rises. So it's going to be going uphill in the beginning. So it's either the first one or the second one. After reaching its peak, it flies for several miles at a constant height to a park. So it's going to stay the same height until it gets to the park where it lands to pick up a patient. So to land, it's going to go down until it hits the ground. So it's got to be this one. And we'll do one more set of 2 problems here. Throughout last month, the Walker family pool was full of water. 3 weeks ago, the pool began to leak and it lost water at a constant rate. The following week, there was a big rain and the pool almost overflowed. It's got to be this first one because it started out constant and then it lost water. All the others kind of were gaining water, which doesn't even make sense. If it's losing water, it's going to go downhill. David is delivering a pizza to Mark's house. He drives at a constant speed toward the house until he hits a traffic jam and has to stop for several minutes. So he's getting closer to Mark's house as he drives toward Mark's house. So it's got to be this last one. There's no other ones that start out getting closer to Mark's house than this one. But this would represent the traffic jam, and then he starts up and goes at a faster speed, which you notice it's a steeper slope. So it's got to be that last one. And that's the end of the lesson. I would actually, before I end, I think I would probably read these out loud like I did as you do them, and that might help you kind of see the picture better. That's my advice to you. Okay, now for reals, I'll end.